Okay, so you're saying it's 4/3 times pi times the radius of 1 times the radius of 2 times virtually the internal radius, isn't it? Yeah. Alright, so you've got 4/3. We know what this is. Now you know what this is. You think it's that. You've measured that to be that.
So the radius of the outside of 1 and 2 is all the way around?
Yes.
Okay, yeah, that's what I did.
That's what the equation on the internet appeared to be. So that one goes all the way around that way. So maybe that's R1, and then R2 was around the outside. Come back in there. Yeah. And then if you were able to split it in the middle, R3 was virtually that there. Yeah? And that was 0.5, I think you said you got. Well, you've got all numbers. There should be nothing wrong with you trying to do that now. So the volume of 1, what did you get?
The volume of rock I got was 25.66.
25.66 cubic centimetres. Which would make sense if you got 3.5 and 3.5. That'd make sense.
That's what I got.
Yep. So this is for one M&M.
Yeah. And then I times it by 51.
Yes, which was our average.
And that equaled 1,312.7.
1,312.7 cubic centimetres.
Yeah.
So in the past where we've gone is we've said, I remember doing the letterbox one, for example. That's a really ugly drawing of it, but remember doing the letterbox one, the letterbox question. They asked you to work out what the volume was of that letterbox. Alright, it's on page 268 or something like that. It's on page 232. Alright, so the letterbox question had 232 and it said, if this is the dimensions of this, what is the volume? Alright. Now, in a way, what you're suggesting now is you're saying, I'm going to create something, whatever, I don't know what you're going to create, but what you're saying is, it's got to take up how many? 1,000?
1,312.7 centimetres.
1,312.7 centimetres cubed. So in a way, you've got your answer. What you've got to do is you've got to work back to say, well, if we're using this formula covered at both ends, we're going to be using 2 times pi times r times h plus 2 pi r squared. Yeah? Alright? Now, if you're saying that, then you've got to get numbers in here and here and here to equal around 1,213. Yeah, 1,313 is what I said. So, granted, you might pick out a height, you might say, look, this is going to be no bigger than 20 centimetres. So straight away you might say, I'm going to make it 20 centimetres. In order for the volume to take all of that, therefore I need to get R on its own.
Yeah.
And go through the process.
Yeah. Am I allowed to do an ellipsoid?
Yeah. Just like we did with this. Remember we did that with your Pythagoras' theorem.
Yep.
And we had to get B on its own, or we had to get A on its own, or whatever. This way, you're doing the same process, but you're having to get R on its own. You've got to go through a process step by step. You've got to take this over, take this over, take that over, until you get R on its own. When you find R, you've got the dimensions of your shape. Does that make sense? Yeah?
I don't know how I'd do an ellipsoid though, because the actual shape created.